remember when we solve radical equations, our first step always is to isolate the radical. So in this case, my radical happens to be on the left-hand side, but it is isolated because everything happens to be under that radical. So as I begin solving, since that's the case, my first step is to remove the radical, and remember we do that by raising to the power of the index. And when I do that as well, I need to be sure that I'm doing it to both sides. So since it's a square root, I'm going to square both sides. Now what I end up with, as a result, left side becomes 5x minus 6, with the radical disappearing, and the right side becomes x squared. So as stated in the notes above, that means I'm going to have a quadratic since it becomes x squared. So in order to solve a quadratic, you may remember that we need to first put it into standard form. Standard form being ax squared plus bx plus c equals 0. I always like a to be positive. So since x squared is by itself on the right, I don't want to move that because it will make it negative. So I want to move these terms here over to the other side. So I'm going to end up with 0 equals, as the 5x moves, it becomes the opposite sign of negative 5x. As the negative 6 moves, it becomes the opposite sign, which is plus 6. So this is now in standard form where I have ax squared plus bx plus c. The equals 0 can be in the front or in the back. So here's my quadratic. And again, remembering past lessons, solving a quadratic can be done in multiple ways. This one in particular, we would like to solve it using the factoring method. So now I want to factor this. I'm going to consider all the possible factors of 6, right? I look at all my factors of c. So it's 1 times 6 or 2 times 3. Or negative 1 times negative 6 and negative 2 times negative 3. Well, which pair of numbers, this one, this pair, or this pair, which pair is going to not only multiply to positive 6, but also add to the negative 5, right? So they need to add up to b, right? So I know my factors are negative 2 and negative 3. So I'm going to have, and the factors that give me the x right from the beginning are x times x, the x squared, sorry. That leaves us with the solving part. So since the entire equation equals 0, I use the zero product property that says either x minus 2 equals 0 or x minus 3 equals 0. Now I have two possibilities, either x equals 2 or x equals 3. So here I have two solutions, but I cannot commit just yet until I check them. So my original equation is the square root of 5x is 5x minus 6 equals x. So I need to take the time to plug in each one separately. First one I'm going to plug in, 5 times 2 minus 6 equals 2, so I'm plugging in there. Does this left side actually equal 2? Well, I get 10 minus 6 And 10 minus 6 is the square root of 4. Yes, the square root of 4 does equal 2. So I know I can circle x equals 2. When I go back to check the other one, I'm going to have to make sure that that also gives me the same answer, that it works. Because at times, the solutions you come out to, they might both work, one may work, both may not work. In this case, I get 15 minus 6. Does that equal 3? That's the question. Well, 15 minus 6 gives me 9, and the square root of 9 is 3, so that one also works. So there are no extraneous solutions in this case, just two solutions instead of one.